is Felipe Bortolon.
I'm the engineering manager for the CellForge solution, and today I will show you how you can speed up your layout generation for CDL, specifically for standard cells and advanced things. Before I get started with the tool itself, it's important to explain why we have the memory. And if you are familiar with layout design, have been working with many generations, you know that every new generation, the sheer number of design rules that you have to comply with have increased. Now, that means the layout effort that you have has increased as well. If we take a look here, for example, from 28 to 7 nanometers, we can see that layout effort has doubled. And we can see that this is mainly due to DRC closure. So it's not only DRC rule numbers that increased, but their complexity has increased as well. On top of that, we know that new advanced structures think fast, did all around, especially those below 10 nanometers, have become very rigid structures with very little space and freedom for the layout design. Now we have multi-patterning designs who have very strict positions that can be placed, have very complex constraints, both with coloring and no coloring. And again, the possibilities what you can do in the layout are very little. So if you find out that your vias are violating a certain coloring pattern, we're left without options to fix that. So that means your initial assumptions, the way you place your transistors, are not valid to create a solution, which means you'll have to start from scratch and replace your devices. Now with that motivation, that's why we introduced CellForge solution 3D, which is specific for those nodes. Although the search space and creativity space, let's say, for the layout designer has reduced, that's actually an opportunity for automation to take advantage of. Now, our tool most interesting feature is the CDL to GDS conversion. You're taking a standard cell CDL and it can convert automatically to GDS based on your user configurations and optimization managers. But in addition, we also offer a full environment for you to work and for everyone on a single domain using the same scripting language and taking benefit to our API to explore your layouts, extract data, or even make customizations. Now, we also don't want to disrupt your existing flow, so we have integration with the major verification codes in industry, and you can launch those codes through our interface and collect back the results. So all the process will be done within a single environment, standardizing the standard cell development process. Now, before we jump into some examples of what the tool does, I'd like to take a minute to explore which flows we can explore this type of tool. So initially, when you take a new technology, the first step is an exploratory process, where you want to figure out which design patterns are valid and which ones are not. You'll therefore iterate with your DRC tool to verify which patterns are valid and which are not, and encode them back in the tool through DRCs that will make you generate DRC clean layouts. Now the next step in your design stage is to go through characterization and see that your layout is actually performing to the standards that you desired. That might as well require some loopbacks to your layout phase, and we can start featuring how much layout effort plays into. And if we have to spend a lot of time on it, won't have time, make those. Similarly, in the PNR level, we'll be faced with additional challenges, being either meeting or timing requirements, or even needing for specialized cells for your products. All of that can be looped back and reconfiguring the tool in a way that everyone can use and create different presets for different libraries. Taking a look on how that looks in practice, using some configurations you can decide how transistors will be placed, generating multiple solutions. For example, we can see here pins and transistors have been placed differently on those solutions, and we can quickly evaluate their timing through a characterization tool. For example, here, Silvaco's Liberty Forge. Now each of their solutions might be equal or better for different scenarios. Another possibility is Each technology has multiple architectures, and you may want to explore them and see what the different impacts they have. So for example, here I have on my right a technology that has 5 metal worm tracks. We can see here 5 tracks per height on a double height cell, and I'm using what we call a 1T1 metal 2 gear. And I can see that I was able to place my flop on a 7 colors. Now I can experiment what reducing one of those horizontal resorts would impact my cell area. So you can see in the next, I have do this reduction. I needed to increase to 9 columns my previous solution. Interestingly, I did a trick here of increasing my metal 2 resources, which are those pink vertical lines. Instead of simply 1T1, I had added more metals, which is called a 2T3 pattern, and that helped me to route that. And we can notice this when we move from 4 tracks to 3, that we could keep the same number of columns because that was enough for it. Next, we can see we also had that cells from different drive strings need to be standardized. They need to follow a certain pattern. You often work on the X1 version and you want the other cells to keep a consistent format between them. And we can also do this. So for example, I took here a seed for an R3, my initial X1 cell, where I got this very nice via pattern, which looks like a staircase. And I was able to reuse that to create larger cells reusing the pattern I carefully crafted during my verification. Now, who is using this in practice? Well, we have some leading semiconductor customers that have been using our approach or 3nm libraries to squeeze as much as they can from their performance. So 3% might sound a small number, but when you are in the extreme edge, getting as many as you can out of your performance, to add 3% by optimizing your library, augmenting is a lot. And in our internal team, we have been using the tool, of course. We have seen a 3x speed up on the layout process because it's automated, the generation. So the engineers are more focused on finding the best solution, figuring out what the impacts will be on the PNR and the impacts on characterization. So it kind of changed the paradigm of spending time on layout design to spending time on thinking about the design and their impact on the solution. As a quick summary of our features, we have a flow, as I've mentioned, to generate from CDL to GDS. We also provide means to reuse your GDS to generate more solutions from the same technology or for similar ones that make sense. We support single and double diffusion breaks, single and double cell heights. As we shown, it's configurable the number of horizontal tracks. The pattern is configurable and you can limit how many stacks you can use of metal to force that solution. We also support backside power and signal routing. We have support for many constraints, including coloring, explicitity or implicit, support for dummy rules, border constraints to make sure the point cells are abutted, the PNR, they are compatible, and of course, we provide constraints that are customizable to define what is a good layout for you. So of course, the basic approach is to reduce the number of vias and the routing length you're using, but there are many other optimizations you can use to improve your characteristics for cell. All of that, in the end, is to speed up the turnaround time in tight market cycles to tape outs. Thank you very much.